Hello, welcome to tutorial 2.0. This is the 7th in a series of tutorials, the aim of which is to help people who are novices at preoperative cardiopulmonary exercise testing understand what's going on. The first 6 tutorials described normal patterns during a preoperative cardiopulmonary exercise test that lasts approximately 13 minutes of pedaling. And this first tutorial in sequences 2.0 onwards is going to talk about abnormal patterns. So, to talk about the abnormal, first of all, we need to define what is normal, and immediately we hit a problem. The problem is that we aren't too sure what the normal value is, by which I mean the mean value for a population with given characteristics. And within the normal population, we know that there is a pretty wide variation in peak oxygen consumption, which is the variable I'm mainly going to be talking about in this tutorial. And if one defines normality as a characteristic of 95% of the population, we would be looking at quite a wide range of oxygen consumptions. Therefore, it would be no surprise to you to learn that there are at least 20 equations that take the patient's characteristics, which usually include age, sex, and might, but not always, include height and weight. And these variables together are combined to generate a predicted value. So the fact that you see one predicted value on your 9-panel plots should not mislead you into thinking that that is the accepted peak oxygen consumption for that patient, because there are lots and lots available. So let me show you my Blue Peter moment. Let me show you some plots I have already plotted out. So what are you seeing here? On the horizontal axis, we have got I'll show black. On the horizontal axis, we have got age. So this is age here. Age in years. And on the vertical axis, we have got peak oxygen consumption in mils per minute. And you can see that there are a number of lines on here. Each of these lines depicts the predicted peak oxygen consumption at a given age for a 170 centimetre and 80 kilogram woman. And you'll see that the values are quite varied. So let's just look at a narrow window at the age of 40. And you will see that you could pick a range of values between 4 litres and right down to half a litre. Now I have taken the liberty of dashing some of these lines so that I thought they're nonsense really, and I have kept this range of lines here solid. The thickest red line is the predictive equation that I use in my clinic, and it's the one that comes with the survival calculator that I developed. The black line is a second equation I'm sort of toying around using in preference to the thick red line. And this is just the variation in peak oxygen consumption for a woman, 170 centimetres and 80 kilograms. Papers reporting peak oxygen consumption do report normality range as often being in excess of a litre. So by definition, if we are calling abnormal the outlying 2.5% above and below, then we necessarily have to conclude that this lot in the middle are normal. And so there isn't a single value. What we do know is that the fitter somebody is, the better their survival, and the less fit somebody is, the worse their survival in the long term. And just for your amusement, I'll show you a shorter and underweight woman, 160 centimetres and 40 kilograms, and with the same vertical axis up to 5 litres oxygen consumption, you can see understandably smaller people would be expected to consume less. A shorter but fatter woman won't be expected, with most of the equations, to consume as much oxygen as a taller but slightly lower weight woman, is what I annotated. Then we can move on to 3 similar graphs for men. Here's a 170 centimetre, 120 kilogram man, so a fat man. Here's a taller, more normal weight man. And finally, same height but underweight man. Okay, so what was the purpose of that? The purpose of that was to show you that there isn't a single predicted peak oxygen consumption, which begs the question of the most common abnormality, which is lack of fitness or being of less fitness. And perhaps we shouldn't really call it an abnormality. We might preferably call it just less fit than some other people. What we do want to know is whether the value reached is more or less than the average reference population. And I'm starting to digress from just talking about cardiopulmonary exercise testing. But if you're using your results to compare against survival in the general population, what you need to know is the mean value in the general population. If you are comparing your value in a patient with colorectal cancer against all the other people you have done CPETs on who've had colorectal cancer, then you're going to use a different population, aren't you? So let's just draw out the pattern of oxygen consumption in somebody who's just less fit. So first of all, we'll draw out the pattern of somebody with a normal fitness. And then we'll draw a pattern of somebody who's less fit. Now, if we've used the same power slope, the unfit person is going to stop before the fit person. If we have looked at the patient and thought, oh, they look a bit unfit, then what we might have done is use a lower power such that the slope is lower, but the finish at the same point. So one of your jobs as the clinician looking after these patients is to decide what ramp rate to use. So do you use a shallower ramp or a steeper ramp or a very shallow ramp, etc. So I haven't answered the question, what is normal peak oxygen consumption? And even more, with more difficulty, would one address the question of what is a normal anaerobic threshold? Because once you've defined your mean peak oxygen consumption, you can then say, what is a normal anaerobic threshold for a given peak oxygen consumption? Well, it can be between approximately 30% and 75%. And just going back to our graph, as somebody ages, as somebody gets older, the ratio of the oxygen consumption at the anaerobic threshold over peak goes up. So what is happening is the variable displayed on this graph, which is peak oxygen consumption, that goes down with age quicker than the anaerobic threshold. So normal values for anaerobic threshold as a proportion of peak will change with age. I'm going to stop there to avoid confusion, and we will pick up later on.